Good day and welcome back to the sixth part of the RDM module of the Data School. In this part, we'll be focusing on data storage. My name is Glenn Tseu. I'm a data curator at the Human Sciences Research Council, and I'm also a PhD student at the University of Pretoria. This presentation is based on the CoData RDA Data Science School that took place in August 2019 in Italy, which was titled An Introduction to Research Data Management, Fair and Open Data. CoData RDA has a mission of advancing science as a global public good. CoData does this by promoting international collaboration to advance open science and to improve the availability and usability of data for all areas of research. CoData supports the principle that data produced by research and liable to be used for research should be as open as possible and as closed as necessary. CoData works also to advance the interoperability and the usability of such data. Research data should be fair, which is fundable, accessible, interoperable, and reusable. The data lifecycle is the sequence of stages that a particular unit of data goes through from its initial generation or capture to its eventual archive and/or deletion at the end of its useful life. This slide indicates on where the data lifecycle storage is located, which is the stage that I'll be focusing on. Once data has been created within the organization, it needs to be stored and protected with the appropriate level of security applied. A robust backup and recovery process should also be implemented to ensure retention of data during the life cycle. Companies also have a recovery process in case of lost or stolen data, which usually involves downloading and restoring information. The first step when looking to store data is to consider where you will store your data. You can store your data on your own device, for example, a laptop, a flash drive, external hard drive, or on a server. This, however, is risky as it can break, can be lost, or can become corrupted. You can also store your data on departmental drives or university servers. Another option is to store your data in the cloud. The question to ask yourself, though, is do they care as much about your data as you do? It is very important that you make sure that you choose a reputable and reliable cloud server provider. It's very important to always store your data in 3 places, which ensures adequate backup. Finally, your decision on where you will store your data should be based on how sensitive the data are, how robust the storage needs to be, and who will need access to the data and when. How to keep your data secure. To keep your data secure, you should develop a practical solution that will fit your circumstances. For example, store your data on a managed service. Restrict access to collaborators or to a smaller subset. Encrypt mobile devices carrying sensitive information. Keep your antivirus software up to date. Use secure data services for long-term sharing. There are different types of infrastructure that can be used to store your data and share your data. Let's look at some infrastructure that can be used to store your data and to share your data. One type of infrastructure that you can use is collaborative platforms such as the Open Science Framework, which was developed by the Center for Open Science. The Open Science Framework is a free and open source cloud-based tool that can be used as a project management tool that supports researchers throughout a project's lifecycle. It is also a very useful tool for collaboration in teams of researchers. It also has a workflow system, and you can link or integrate many of the tools that you are already using into it. Another type of infrastructure is data-specific platforms. For example, Omario, which is used in the open microscopy environment. Third-party tools for collaboration can also be used. For example, Dropbox on Cloud, which is an open source product with Dropbox functionality that is used by many universities and service providers. Just remember that these platforms belong to third parties, which can be risky. With OnCloud, however, you have the option to deploy OnCloud on-site at your institution in your own data center, which can make it more secure. Many higher education institutions have their own research data management infrastructure. For example, the University of Edinburgh that you can see on this slide. The University of Edinburgh has a data storage, a compute and data facility that can handle high-performance computing, a data sync service, a wiki service, electronic lab notebook, a data share repository, a data vault, a pure system that handles research information, and a secure data service. The University of Pretoria is working towards using similar platforms. At the University of Pretoria, 3 main processes have been identified, which are focusing on the research in process stage that is covered by systems such as Alfresco, eLab notebooks, departmental servers, and institutional Google Drive, and the UP DMP tool, which will be rolled out in June this year. The dissemination stage that is covered by the UP Research Data Repository, which runs on Figshare. The preservation and archiving stage, where the research data would be preserved for long term. Here, we are looking at the Library of Congress's Bagged specification and the possible deployment of Archivematica. This slide just gives a more detailed overview of services in each of the 3 stages as discussed in the previous slide. With regard to the backup and saving of data files during the research in process stage, we use an institutional Google Drive instance where researchers have unlimited storage space. Currently, UP is using the Research DMP tool and the Digital Curations DMP online tool for data management plans. We already have a DMP template available for UP researchers and plan to launch our own UP DMP tool in June of this year. In the dissemination stage, we are using Figshare as our research data repository. DOIs can be added and metadata can be added through Figshare. With regard to long-term preservation of data, UP is currently testing Archivematica as a possible solution. It is very important to remember that data storage, backups, and archiving are not the same. Data storage is the process of preservation of data files in a secure location which can be accessed readily. Data backup is the process of preserving additional copies of your data in a separate physical location for data files in storage. It's used to take periodic snapshots of data in case the current version is destroyed or lost. Backups are copies of files stored for short or near long term, often performed on somewhat frequent schedule. Data archiving or long-term preservation is the archiving of data long-term to preserve the data for historic potential disasters. This is usually the final version and is generally not copied over. Data archiving is often performed at the end of a project or during major milestones. Let's do a recap of what was covered in this session. We focused on different types of storage and stressed that it is good to store your data in 3 places. We also looked at how to ensure your data is secured. Next, we looked at different types of infrastructure, collaborative platforms, data-specific platforms, third-party tools for collaboration, university RDM services, RDM services at the University of Pretoria. We ended the session by describing the difference between data storage, data backup, and data archiving. This is the end of part 6. Please go to part 7 on data sharing and preservation.